Hi guys, Dr. Diaz here again. Let's now solve this problem for the ellipse. This is a little bit more of a challenge one, and we're going to do is find their center, vertices, focus, and eccentricity. And this is more or less what we're going to do in most of these problems. So the first thing you do, you see the equation, it looks a little bit complicated. It says 4x squared plus 16y squared minus 8x minus 96y plus 84. Okay, this does not look like an equation of an ellipse, but the first thing you have to do is you have to turn this into the equation of an ellipse, and I'm going to show you in a second how this equation should look like. And what I was saying is we like the equation looks like one of these two. Ellipse centered at the center HK, and actually we will look at the equation of ellipse in the standard form, right? One of these two, if it's a line along the x-axis or it's a line along the y-axis. So how we turn this equation into one of these two? Well, the first thing, we have to regroup x squares with x, y squared with y. Whatever is not an x or a y, we send it the other side of the equation. Okay. Now what we do, we take in common factor here, 4, and here 16. We'll get something like this. Now that we have it in this form, we start proceeding. You remember these two? This looks like the same thing we used to do in the past. Oh, I forgot the y here. We had to do completing the square. We look at the middle term, negative 2 in here, divided by 2, and we square it, which is going to be negative 1 squared is equal to 1. Then we take here negative 6, we divide it by 2, and we square it, which is going to be negative 3 squared, that is going to be 9. And then we're going to do this, 4x squared minus 2x plus 1 plus 16 y squared minus 6y plus 9 is equal to negative 84. But look what happens. If we added 1 here, we had to add 1 here, but this one is not 1 alone. There is a 4 in front of it, so this is going to be basically 4 times 1 is what we're going to add here. Not just 1, but there's a coefficient in front of it, the 4. We take as a common factor, it will be 4 times 1, 4 we added here. Plus, the same thing is going to happen. We're not going to add just 9. We're going to add 16 times 9. And 16 times 9 is 144. 16 times 9 is 144. So we will have 84, negative 84 plus 4 plus 144, and this is going to give us, I think it's 164. This is actually 64. Perfect. And then we have here 4, and now because we did here the completing the square, what we did here, we turned this into a perfect square trinomial. X times something square, and what is the something here by completing the square? It's always going to be this number here. So it's negative 1. The same thing we did here with the y. We have the 16. The reason why we get this number, we divide by 2 and we square here, is because we turn this expression into a perfect square trinomial. So it's always going to be y, and what number goes here, square, what number goes here is going to be always this fellow. The one we took here is negative 6 divided by 2, which is negative 3. Negative 3. Now, still doesn't look like an ellipse. Let me scroll down a little bit. But now we can see that if we divide everybody by 64, because remember, the equation of ellipse is equal to 1. So then we go here, we divide by 64. And here by 64. And here obviously by 64. We will have then x minus 1 squared divided by 16 plus y minus 3 squared divided by 4 equals to 1. And now this does look like one of these equations where the center of these ellipses is h and k, and in this case h is negative, and actually it's going to be positive 1, right? It's going to be opposed to the sign that is there, and positive 3. So we have the ellipse with the center 1 and 3. Perfect. Now we have to find is the focus and eccentricity. We're going to do this in a second. So let's do the first thing. A squared, scroll a little bit up. Okay, we're going to scroll up. Is equal to 16. So A is equal to plus or minus 4. B squared is equal to 4. So B is equal to plus or minus 2. This is a semi-minor axis, semi-major axis. We know it's a line along the x-axis because 16 is bigger than 4. Now what else we need to do? We need to find the focus. And the, oh well, first of all, C, the value of C. For an ellipse, C is going to be equal to the square root of a squared minus b squared, which in this case we have it as square root of 16 minus 4. It's going to be the square root of 12, which is going to be what? 2 square root of 3, which this is equal to 3.46. Now that we have C, let's try to find the focus. And for an ellipsis, we need these two equations. So the focus here, when the ellipsis is aligned along the x-axis, it's going to be h minus c and k, and h plus c and k. We already have h. Oh, we forgot what's okay. Yeah, we have h here is 3 and 1. So this is going to be what? 1 minus c, which is 3.46. So 2 square root of 3. Doesn't matter which one you want to put there. And k, which is 3, and the other is going to be 1 plus, which you can put 3.46 if you want, and it's going to be 4.46, or 2 square root of 3 and 3. Right, good. We have the focus now. We haven't to draw this thing yet, but we're going to draw this in a second. Now we have to find the vertices. And again, because this is a line along the x-axis, the vertices is going to be h minus a and k, and h plus a and k. So in our case, this is going to be 1 minus 4 and 3. And this one is going to be 1 plus 4, well actually, which is going to be 3 and 3. And then the other one is going to be 1 plus 4 and 3, which is going to be 5 and 3. Okay, well, and then it should make sense because these points, they should be aligned with the center. I mean, it's a horizontal line, and those 3 points should be collinear. And well, the eccentricity, let's put it here. It's going to be E is equal to C divided by A. We already calculated C as 3.46, I'm sorry, divided by 4. And if you do that, look here to calculate, we got the eccentricity is 0.865. Okay, so now let's try to graph all this. So now let's go and start graphing this thing. For example, we should look for the center, which is 3 and 1. So let's graph that 3 and 1. Oh, sorry, I have to look back again. It's not 3 and 1, it's 1 and 3. When x is 1, y is 3. So we go here 1, 1, 2, 3. Here is the center more or less. Mistake. 1 minus 4, yeah, because I saw those 3-point collinear, they're not in the right place. 1 minus 4 is actually negative 3. Sorry about that. So this one, when x is 3, y is negative 3. So here we go. Negative 1, negative 2, negative 3 is here. Oh, what a buffon. And the other one, when x is 5, we have here 1, 2, 3, 4, 5. And this one, now they look collinear. Now they look perfect. Okay, this is a semi axis. Well, this is the distance there, the center, semi-axis measure. We need to find the eccentricity. Well, we have the eccentricity. Did we find the focus there a moment ago? It was 3.43. So 3.43, we have 1, 2, 3, 3.43, somewhere around here. It will be 3. Let's scroll up so we can see the number. Yeah, we got it there, 3.43. So it will be 3.43 and minus 3.43. No, actually it's 3.43, and actually it's not 3.43 again. What a tonto. It's actually these numbers, which the first one will be 1 plus 3.43 is going to be 4.46 and 3. That's the focus, right? That's the focus. So here we go. 4.46 and 3 is somewhere around here. This is the focus. The other one is going to be then 1 minus 3.46, which is going to be negative 2.46 and 3. Right, 2.46 is somewhere around here. Yeah, I have to look collinear. Right, perfect. And now we got here the the minor's axis, which is h and k plus b, h and k minus b, which we will have 1, 3 minus 2 is going to be 1 and 1, so it's going to be around here. Next is 1, y is 1, and the other one is going to be 1, 3 plus 2 is going to be 5, so that one is going to be 3.5. And actually here is our ellipse. Here looks like this. Go here. Oh, okay, I missed badly there. There it is, more or less. Where the center is somewhere around here, and the focus looks like that. Well, this looks like an alien, but at least this is what we're supposed to do. You probably would do it much better. Okay, guys, let's see the next video in a second, which I'm going to solve another problem. Bye.